In this video, we're going to concentrate on the fundamentals of creating your own custom meshes, rather than relying on create primitive and the different primitive types that Unity provides. First, let's right-click in the hierarchy and create a sphere in the scene by going to 3D Object and Sphere. Go ahead and select it and look at it in the Inspector tab. As we've previously seen, it has a transform which controls the position, rotation, and scale of the object. However, below that are two additional components that together cause a 3D model to be created and drawn to the screen. The first is the Meshfilter. The 3D data is stored within a mesh object inside of the Meshfilter, which is called Sphere here. The mesh contains several arrays. If we were to create our own list of points and also describe how they should be connected, we can then create our own 3D model. The bare minimum requirement for a mesh is an array of vector3s, which are vertices or points. The next array we need to provide is an array of indices, which tell the computer how to construct the object from the list of points. We also need to inform the computer how to use the indices. That is how the data is represented. Examples include whether we draw points, lines, triangles, or quads. If you're having trouble with this idea, think of a game of connect the dots. The vertices are the points scattered around the page, and the indices are the order you connect them in. In connect the dots, you normally use what is called a line loop, where you start at 1 and do not lift your pen until you reach the last number. In computer graphics, we're not limited to just the line loop. There are many shapes possible, but Unity restricts us to the following mesh topology enums, specifically triangle, quad, lines, line strip, and points. Now, just to warn you, there is more to making a polygon object. One such thing to consider is the winding order, which determines which side is the front or the back. In Unity, the winding order is clockwise, the same convention as in DirectX. OpenGL happens to use a counterclockwise winding order. So why is this important? Well, if you can't see your object as you're constructing it when you hit the Run button, one reason might not be that you did it wrong, but instead that you're facing it from the wrong side. That is, turn 180 degrees around the object and you'll see it from the other side. Let's create a simple triangle. Let's go ahead and create a new script called triangle and attach it to an empty game object. So let's go to our project, right-click, create. I'm actually going to create a folder first and just call this scripts. Then I'm going to go into scripts, right-click, create, and then let's go to a C# script. Let's call this triangle. Go ahead and double-click on it to open it up in your preferred IDE. So here we have our skeleton framework that Unity provided us for our script. What we're going to do is create our own method called Generatemesh. It's going to return to us a mesh object, and it's not going to take any parameters. So let's go ahead and do a public. There's no reason not to make it public right now. And it's going to return a mesh object, and we're going to call this Generatemesh. You'll immediately get a red squiggly line indicating that we have an error. Don't worry about that error yet. It's just because we haven't created and returned a mesh object yet. We'll get to that soon. Now we need to create some lists to hold all of our vector data. Now you can use an array if you'd like to. The only benefit to using a list is that we can just add elements to it as we see fit, and it can grow and shrink in size very easily. If we happen to use an array, we need to make sure we calculate at the beginning exactly how many array slots we would need. Now for a triangle, that's easy, it's 3. But for some more procedural algorithms, it can become a little bit more difficult to understand or know exactly how many you need at the beginning. So let's just use a list for now. So let's do a list, and then the type we're going to hold are vector3s. Once again, because we're holding vertices or three-dimensional points in space. And let's call this vertices. Let's do new list of vector3. So there we go. So we have our variable here, and we have created our list here. Next, let's create another list. This time it's going to be of type integer, and it's going to be our indices. Once again, new list of type int. Now let's create our 3 vertices or points to go into the vertex list. So we'll do vertices.add, and then we'll specify 3 points. The 3 points we're going to create are at 0, 0, 0, 1, 0, 0, and then 1, 1, 0. So let's go ahead and do a new vector3, and then we will do 0, 0, and 0 passed in. So let's go ahead and do a new vector3, and this one is going to be 1 over in the x direction. So 1, 0, 0. And then let's go ahead and do vertices.add, and we'll do the final one, which will be new vector3, and we will do 1, 1, 0. And those are our vertices. However, we now need to create the index list to tell the computer which vertices to use as it draws. So let's go ahead and do indices.add. So rather than start at 0 here, I'm actually going to start in the middle. So why don't we start with, so this is index 0 here, and this one is index 1, and this one is index 2, because we are 0 based in terms of indices. So indices.add, we'll add 1 first, and then we'll do indices.add, and this time we'll do 0, we'll go backwards. And then the next one we'll do is indices.add, and then we will add a 2. Now we need to create that new mesh object that we're going to return and fill it with this information. So let's do mesh is equal to a new mesh. Now we need to transfer data into the mesh. And Unity actually has two different ways of doing this. If you're confident that you constructed your mesh properly, you can directly assign the vertices as an array, such as by doing mesh.vertices is going to be equal to vertices.toArray. This is going to take our list and convert it to an array. This doesn't do any kind of checking, though, to make sure that what we're doing is right. However, since we're already using a list, why don't we go ahead and use a helper method called setVertices to help us out and see whether or not things are correctly put together. So let's go ahead and do mesh.setVertices. And what we can see here are different parameters we can pass in. You'll notice that this particular version has a list of vector3s, which is perfect for us. So let's go ahead and type in vertices. Next up, we need to call setIndices. So let's do mesh.setIndices. And then we need to pass it several different arguments. However, if we move down through the different parameters that it can take in, we'll notice that 1 is a list of indices. So it's entirely up to you. We could do indices.toArray if we wanted to, or you could just pass in indices yourself. Next up, we have to specify the mesh topology. So I'm going to go ahead and hit enter to automatically grab that enum, and then we can see the different types. For now, let's start with points. Next up, we need to provide a submesh value. We're not going to be using submeshes in this example, so go ahead and just enter a value of 0 for now. Now I will say there are more advanced methods inside of Unity for defining your mesh. For now, concentrate on using these easier methods first before moving on to the more complex ones, where you deal with the individual buffers themselves and have to understand how they work together. Now let's return our mesh object now that has been set up and created properly. So we can do return mesh. Now we need to call Generatemesh so it actually happens and creates our mesh for us. And then we also need to take that mesh and stick it within our Meshfilter. So first, let's generate our mesh. We'll do Generatemesh. And let's just set that equal to mesh. But before we get to that point, let's go ahead and see if we have a Meshfilter to attach to it. Because if we don't, we either need to create one or we do nothing and don't even call Generatemesh. So we'll do Meshfilter mf is going to be equal to this.getComponent, and then we'll look for a Meshfilter. Now we need to check whether or not Meshfilter is null. So if mf is equal to null, well, if it is, in our case, we're not just going to abandon things. We're going to create a Meshfilter and attach it to that object. So we'll do this.gameObject.addComponent of type Meshfilter, which will generate a Meshfilter for us and attach it to the object. AddComponent returns to us the Meshfilter object, so we can type mf is equal to this.gameObject.addComponent. Now one issue is we might want to use the Meshfilter later on. And by having the Meshfilter declared in start, this variable will disappear once we leave this method. So let's move this up here and create a Meshfilter, and then call this Meshfilter because that's a slightly nicer name than mf. And I'm just going to set that equal to null. Now I'm going to replace mf with Meshfilter down here. I'm also going to remove this declaration of Meshfilter, because this will actually cover up this one up here if you're not careful. So get rid of that. And now we're ready to go. So let's do Meshfilter.mesh is going to be equal to our mesh object. The last thing we need to do is make sure that we have a mesh renderer attached to our object, because if we don't, nothing's actually going to show up on the screen. So let's do another check. Let's do a mesh renderer, and this time we're going to declare it up here first. Mesh renderer is going to be equal to null. And then down here, let's attempt to grab it. So we can do mesh renderer is equal to this dot get component mesh renderer. Now let's check if mesh renderer is null. Then we're going to create one. Once again, grab the name mesh renderer, paste it here, is going to be equal to this dot game object dot add component mesh renderer. And now we would have checked for one and seen that there is one attached, or if one isn't, we have now added one to the object. Now with that, let's go back to Unity, attach this to an empty game object, and hit run to see what happens. So go ahead and delete our sphere for now, right-click, and go to Create Empty, and let's call this Triangle. Go ahead and grab your script and drag it into the inspector to attach it. Now, if we go ahead and hit run right now, we're going to run into a little bit of a problem that will probably cause a lot of frustration if you don't pay attention. The reason is because you'll notice that Triangle has a mesh filter, which we generate and create. And if we double click on this mesh object, you'll notice that it says we have 3 vertices and 3 triangles. Don't worry about the fact that it says 3 triangles. We're using points here. But if we go back to Triangle, we'll look at our mesh renderer and notice that under materials, there is no material. The material describes the properties of how to draw the object. If you don't have a material, it doesn't matter that you have a mesh renderer. So let's go ahead and create a quick material. Go to your project, right-click, create, and create a new material. Call this triangle_M. Now this is not a discussion on materials. We're simply giving it one so that we have something to draw with. At the top, you'll notice shader, which specifies different ways or different programs that dictate how to draw that object. For right now, I'm just going to click on unlit and we'll do color. This is a very basic shader that will just draw a color that you specify as main color to the screen wherever your object is. So let's click on triangle, grab our triangle material, and go ahead and put that in element 0 of our mesh renderer. Now, as soon as you do that, what you might notice is that you can begin to see the points of the object. Now, they're very, very small. And the reason for this is because point is literally a pixel on your screen. So here you can see the orange outline and the white coloring of those different points. If we go back to our triangle and we change this to something else, maybe red instead, and then we go back and select our triangle and we try to zoom in, it doesn't matter how far you zoom in, that point will never get any bigger because it is a point. So we know we can draw things and we know we can get them to show up on the screen, but those red dots don't help us very much. So let's go ahead and convert these over to triangles. Let's jump back into our script. So what we want to do is create triangles. To do that, we need to go under mesh.setIndices and change this to triangles instead. Now we also need to make sure our indices make sense. Before we were working with points and points could be in any order. Now that we have triangles, we need to make sure that we're working in a clockwise fashion. So if we were starting at indices.add1, that is this one right here, the next one we would go to in order to complete a clockwise revolution would be 0. And then we would come back around up to 2. So luckily, we don't need to change anything. So let's go ahead and hit save, minimize this and go back to Unity. Let's go ahead and hit run. And then once again, what we'll notice is that our triangle is not visible on the screen. If we hit F to frame up, we'll see that nothing's there. And once again, this is because we do not have a material associated with that object. For now, let's just drag and drop our material onto that. And then here, you'll notice that we now have a triangle that we have created. Really important is the fact that if you look at it from one side, you'll notice it disappears, and the other side, you'll notice it doesn't. Once again, that is backface culling, and you need to make sure that you do things in the correct order for them to show up. Now, it is true that you can determine which direction is culled, or that no directions are culled, but I recommend you get used to creating all of your objects using one convention. Now, one thing you'll notice is that because we're using an unlit color shader, that is, it does not do any lighting information, all we're getting on the surface is the solid color that we chose, which is this red. So if we come down here and choose different colors, you'll see that the whole object becomes that color. However, if we choose the light source and zoom out and then rotate it about, what you'll notice is that regardless of where the light is pointed, the object remains the same color. Now, even if we go to the material and change the shader to something that isn't unlit, say the standard shader instead, you'll notice that it does change its color. However, is it responding correctly? The interesting thing here is that if I move this light source, so it's a little bit easier to see. So let's move this down right in front of this triangle. If you look at this object, and if we go to gizmos up here, we can actually reduce the size of that 3D icon so it's not so big. These light rays are pointed directly at the surface of this object, directly at it, but the object still appears completely dark. And if we rotate this around, what we'll notice is that if we rotate it facing, say, this direction, the z forward vector in this case, or negative z actually for the world space, what we'll notice is that it actually appears lit up. We need to provide to Unity the normal information for this object so that it is lit correctly. And that's what we'll begin to discuss in the next video, how to add additional attribute values, that is per vertex values, such as color and normal information, to make this object a little bit more interesting.